Now we're going to talk about sexual reproduction. And the first thing we need to make sure we understand is that when you're talking about sexual reproduction, you have various traits, but we have variety available. Whereas in asexual reproduction, all the E. coli look alike, in sexual reproduction, we have the chance for the offspring to look different. And so, what I have here is a trait. And in this case, we're going to talk about dominant traits versus recessive traits. And so, this is a widow's peak. And if you look at her hairline, you can see that there is a code inside of her genetics that says that her hairline should come down into a V shape on her forehead. Now, that is a dominant trait. And not having a hairline, widow's peak, having your hairline be completely straight across, that's a recessive trait. So let me show you what this will look like. Right, so I have these traits that I've listed, and I've also clarified that having a widow's peak is a dominant trait, not having a widow's peak is a recessive trait. Now, dominant traits, when we do their abbreviations, we tend to use capital letters. Now, I could really use any capital letter I wanted to, but I'm going to choose to use a capital W because I'm talking about a widow's peak. Now, no widow's peak is a recessive trait, and we tend to take this very same letter and make it a lowercase version to show that this trait, having no widow's peak, is recessive. So in the picture, we saw that she had a widow's peak. She has two genes that code for that. She got one of those from her mother, and she got one of them from her father. So maybe she got a widow peak gene from her mom and a widow peak gene from her father, in which case she carries both dominant genes. So, yes, she will have a widow's peak. But what if she inherited a dominant gene from one and a recessive gene from the other? So she got a gene that says, yes, you have a widow's peak. And then she also had a gene that says, no, you do not have a widow's peak. She got the recessive version. Well, when I look at her, which one of those will win out? Well, since widow's peak is dominant, it hides the fact that she has that recessive gene. So when I look at her, yes, she does have a widow's peak, but she carries that recessive trait. It's just you can't tell when you look at her. If someone did not have a widow's peak, then that means they got the recessive gene from their mother and the recessive gene from their father. That's the only way recessive traits show up, is when they get paired with other recessive genes. So is it possible for two parents with a widow's peak to have a child that does not? Absolutely. Right? If both parents are this, where they have a gene for a widow's peak and a gene that says no widow's peak, if parent number one gives away their recessive gene and parent number two gives away their recessive gene, you'll have a child that does not have a widow's peak. Now, that gets us into meiosis. So perhaps I'm going to show inside of the cell, realize there's a lot more information. Let's say I have someone who has a gene, two genes that code for having a widow's peak. Now, if I go back and look, let's see their next one. Oh, if your pinky finger bends in, that's a dominant trait. If it is straight, that's a recessive trait. So maybe that whoever this person is right here, let's say they got the recessive trait that says your pinky does not bend in, and they got each one of those genes from each one of their parents, and I decided to make a B stand for that. And crossing thumbs, let's go down to another one. Tongue rolling. Tongue rolling is a dominant trait. If you can do this, you carry a dominant gene. If you cannot fold your tongue and roll your tongue, then you carry the recessive trait. So I'm going to use a capital T to stand for the dominant gene, a little t to stand for the recessive trait of being you cannot roll your tongue. And we will have this person have both. They have a tongue rolling gene, but they carry the recessive you cannot roll your tongue gene. Of course, this person would be able to roll their tongue because their dominant gene that says you can roll your tongue wins. So what happens? This is going to be when we have sexual reproduction. How do these things reproduce when you have individuals that reproduce through sexual reproduction. The first thing is we're going to show meiosis. Now, again, don't worry too much about writing on your paper just yet. We'll get to that point later. Just watch this, and at the end, I'll make sure that you understand that, what to write down. So let me show you how meiosis works. Meiosis works because this parent, their cell, oh, this is going to sound familiar. In order to start working on producing offspring, it's got to duplicate all the information in the cell. That's 4 W's. It's kind of hard to tell, but see how I just duplicated that? Then it's got to duplicate its no bending little finger genes. And then it's got to duplicate those tongue rolling or not rolling genes. So that was step one. Step two is this cell is going to divide. And it can get a lot more complicated than this, but I'm simplifying it. I'm just going to take half the genetic information and put it over here, and half the genetic information and put it over here. So see, if you look at this point, this looks suspiciously like mitosis. And really, if it did stop right here, this is how we reproduce things like skin cells. We do mitosis. We say, oh, we need more skin cells. Duplicate the information, do one cell division, and we've got new skin cells. But that is not how we reproduce. So we've got to go further for reproduction. I'm going to scoot this up so that we can see everything a little bit more. So now we are going to, at this point, this cell is going to divide. And then this cell over here is going to divide. Move a little higher so you can see it. And again, I'm a disclaimer, right? This can be a little bit more complicated, but I'm going to take half this genetic information and put it over here. And I'm going to take this half of this genetic information and put it over here. And I'm going to do the same right here. So this is mitosis. And excuse me, not mitosis. This is meiosis. And if you'll notice that there was not just one single cell division, there were two cell division. There was a cell division that occurred right here where this one cell became two. And then there was another layer of cell divisions that occurred right here in this place. So we would refer to that as two cell divisions total. Again, this is meiosis. And these down here, right, we still produce daughter cells, but look at how these daughter cells down here are not, I'm going to take this parent. See, they're not genetically identical to the original cell, right? And if you notice, this only has half the genetic information that this one did up here. When you have these, you call these gametes. So you'll notice that in this case, that there are 4 daughter cells produced, and we refer to them as gametes because they only have half the genetic information to make an offspring. Now, in a female, we would refer to these gametes as an egg. In males, we would refer to these gametes as sperm. And it really is the fusion of gametes, right? If I could take a totally separate gamete from another person and fuse it with this, and it had a second set of information. So this is an egg and this is a gamete from a sperm. And if I take these two gamete cells and fuse them together, now I have enough genetic information to make an offspring. So this kind of cell division obviously takes longer. It's more complicated, but it allows for variety in the end. So on your paper, what I would write down is I would write down myself a little note that, in sexual reproduction, that is going to occur by meiosis. And then I would just show these steps happening, right? I started with a cell. That then duplicated its information. And then you would draw this. And then you would show this layer of cell division and draw that. I'll move this so you can do that.